Okay, we are live, right?
Yes, we are live.
Okay. নমস্কাৰ সকলোকে আৰু সকলোকে ওয়েলকাম আমাৰ আজিৰ ক্লাইমেট ডায়ালগ ৱে ফৰৱাৰ্ড সিৰিজৰ আজিৰ খণ্ডলৈ। সো আজি আমাৰ মাজত আছে Dr. Tamanna Subba. Welcome, Tamanna. And she's joining from New York. So I hope meeting khonor time to karu karone extremely inconvenient hua nai. So we'll be talking about some budget in the atmosphere jeneke amar সপ্তাহটোৰ বা মাহটোৰ টকা পইচাৰ খৰচৰ বাজেট থাকে কিমান পইচা আহে কিমান যায় তেনেকে এটমস্ফিয়াৰ এটা বাজেট থাকে যিটো বাজেটৰ বিষয়ে আমি তামান্নাৰ লগত কথা পাতিম আৰু তাৰ আগতে before we go ahead with the session about our speaker, Dr. Tamanna is from Kalimpong, West Bengal, and she did her schooling in Rockvale Academy and Dr. Graham's Homes. Then she completed her BSc in physics from Lady Brabourne College in Kolkata, and then she did masters in physics from Jadavpur University. তাৰপিছত তেওঁ PhD কৰে Dibrugarh University পৰা atmospheric science-ত and in 2020 তেওঁ PhD শেষ কৰে and her PhD topic was investigation of aerosol radiative forcing for distinct source processes, an observational and modeling approach under the aerosol radiative forcing over India AFRI project of ISRO. আৰু তামান্নাই PhD কৰি থকা সময়ত she received Fulbright-Kalam Climate Doctoral Fellowship, under which she visited Pennsylvania State University in 2017 and 18. Then as she worked in the University of Michigan as a postdoctoral fellow, and currently she is in the Brookhaven National Laboratory in New York. আৰু য'ত তেওঁ জুন 2022 পৰা কাম কৰি আছে as a research associate. আৰু her work is on observing and modeling aerosol chemistry, including biological aerosols. Biological aerosoলৰ ওপৰত আজি আমি অলপমান কথা পাতিম. And in addition to her research, Tamanna also loves painting and hiking in her spare time. So welcome again, Tamanna. And yeah, couple of 2 minutes from your opening statement before we go ahead with the question and answers.
Thank you so much for the great introduction, and Nobonita and Bidyut. I'm very grateful to be talking to everyone in today's platform, and I really appreciate Anazori initiatives to consider like broad platforms of, broad subjects of interest. Sabor karane, it's very relative. So, and it's reaching a lot of people out there. So I'm very thankful for inviting me. Thank you.
Thank you. So yeah, without further ado, we will start the question and answer session. So আৰম্ভণিতে what is your current research about? যেটোৰ পৰা আমি আৰম্ভ কৰিম, just briefly for everybody. Your current research about.
So currently Brookhaven National Laboratory, I'm mostly involved in measuring and modeling aerosol processes, basically atmospheric processes, including microphysical and meteorological processes. Are hitu karne moi measurements law or field campaign or participate koro, and also perform different model simulations. So integrate koripine. We try to understand the role of aerosols in climate via radiation budget. So we try to understand the impact of aerosols on our radiation budget.
Okay, so thank you briefly telling. So one thing that fascinates me every time, যেতিয়া মই শুনো মানে field campaign. So কেনেকুৱা ধৰণৰ field campaign do you participate in normally? Like কেনেকুৱা হয় field campaign বিলাক?
So এইটো field campaign to মানে যোনটো আমাৰ ইণ্ডিয়াত হয় or যোনটো ইয়াত হয়, they are very similar. মানে field campaign মানে এটা full seasonৰ হ'ব পাৰে, মানে আমি যোনটো ডিব্ৰুগড় ইউনিভাৰ্চিটিত কৰিছিলো কি whole winterত আমি 24 hours measurement লৈছিলো, যেতিয়া আমি if you wanted to study fog or if you wanted to study like winter or pre-monsoon, আমাৰ যোনটো বহুত biomass burning হয় এইটো capture কৰিবলে field campaign কৰিছিলো। আৰু ইয়াত যোনটো কৰো আমি, it is mostly depending on the weather condition, তো আমি য'ত convective activity হয়, then we try to capture the convective activity in that particular area. So আমি য'ত তেনেকুৱা extreme weather events থাকে তাত আমি যাওঁ আৰু আমি আগতে মানে prepare কৰো কি এইটো featureটো আমি capture কৰিব লাগিব in our measurements. তো আমি হেতু জায়গাত যাওঁ আৰু আমি we try to measure different parameters of the atmosphere like aerosol parameters. Junto aerosol mani these are small particles that are spread in the atmosphere in the form of solid and liquid, and sometimes they are also mixed. Aru etur bahut properties thake junto mass hoy ya number hoy ya size hoy, to ami egita parameters measure koru. To beleg field or pora cloud measure kore, different cloud or properties measure kore. And field campaign to mane amar ground hobo pare aru space mane aircraft measurement hobo pare, aru etu ami balloon measurement so hoy. Again moi Dibrugarhৰ example no, ami mane junto ami radio sound launch korisilu, so hetu eta field measurement etu dhoroner hoy. Yes.
Oh, that's so field তুমি এয়াৰক্ৰাফ্টত নিজে গৈছা?
মই unfortunately এতিয়ালৈকে মই নাই যোৱা, আৰু ইণ্ডিয়াত মই তেনেকে এটা হৈছিলে GWEX বহুত yearsৰ আগত, but ইয়াত মই যোনটো কৰিছিলো এইটো আমি last summerত মই যোনটো ইয়াত কৰিছিলো, it's not aircraft but আমি balloon মানে সৰু 700 grams or balloon launch হয় য'ত সৰু radio sound launch হয়, but ইয়াত মানে বহুত it's like a huge balloon as big as a building, as tall as a building. So etu ডাঙৰ balloonot ami aru ডাঙৰ instrument to পঠাব পাৰো, তো তেনেকুৱা field campaign participate কৰিছো, but not in the aircraft as of now.
Okay, yeah, so
that sounds interesting.
That really sounds interesting. Aru amar mane session to ami to try koro je kisuman terms amar audience or agot we try to make it put it in a simpler form. So to me radio sound is like it's a balloon and then you tie the instrument which you are telling as radio sound. Some of us know what radio sound is. Our audience or kind of, would you just simplify what a radio sound does, or how big it is normally, or how heavy it is?
So radio sound আমি যোনটো ডিব্ৰুগড়ত পঠাইছিলো এইটো মানে it's like roughly 6 by 6 centimeter maybe in a box, so that GPS থাকে, তো য'ত যায় আমি track কৰিব পাৰো, and it has sensors for temperature, humidity and pressure. So it is a simple instrument, it is not very expensive. So I mean it mane pothao aru it's not collected all the time. So it's like it goes as a waste, but jetia uporot jai or tolot ahe hitu time ami continuously measurement to loi thaku, temperature, pressure. So ami jonto grounded measure koru, eto altitude wise eto radio sound to measure kori thake, aru after reaching like 1500-200 meter eto balloon to jetia burst hoy tetia mane radio sound to tolot ahe aru it just gets destroyed in the process of landing. So yes,
1500 I think 1500 2000 meters. You
Yes.
want yeah, 2 kilometers.
Yes, but some of the balloons can go beyond, and
Okay.
some balloons can go beyond 3 kilometers. But average, it's up to boundary layer or level or manitenike jai.
Great, great. So yeah, it's good to know about radio sounds in a very simple words. So yeah, we can keep talking about radio sounds, but I wanted to ask you about one more key thing that you mentioned, যেটো তুমি কলা যে তোমার এই measurements বিলাক করা to understand radiation budget. So budget, which is in the title of our session today. So a budget to বিষয়ে তুমি কও, what is this budget about?
Yeah, তুমি যেনেকে explain করেছিলা, budget is like a plan or outline of the expense, basically. How much money is coming in, jiman ami spend koru, aru jiman ami save hoy. So there is always a balance going on. So teneke amar atmosphere to at a budget thake, juntu is, we refer it to as radiation budget. Now, why radiation budget is because our Earth system is driven by solar energy. So hence the term, the radiation comes from that. So the radiation budget, the term, it means like a balance of incoming energy versus outgoing energy from the Earth system. So incoming energy to amar mostly mane amar solar energy thake. But outgoing energy also includes the outgoing long-wave radiation, Earth or Porajun to Ulai. So there is always like a mismatch going on. Mane amar pre-industrial period or it to almost balance out asile. But of course, after the intervention of humans, mane jiman energy to Earth or atmosphere bhitorot ahe, he too is much more, not much, but it's more than the amount of energy যোনটো বাহিৰত ওলাই। So মানে বহুত energy আমাৰ atmosphere ভিতৰত trap হৈ থাকে। So there is an imbalance of energy, heat in and heat out or ভিতৰত imbalance আছে। So now this imbalance is important because এইটো imbalance to আমাৰ temperature change কৰিব পাৰে, আমাৰ climate pattern to change কৰিব পাৰে। That is from where that is how the climate change is much more relevant in terms of radiative forcing, or these two terms are tied together in short. So so in these processes, like bahut parameters thake or factors thake juntu etu koribo pare, etu imbalance to anibo pare. So we are interested in understanding egita different imbalances to ki hoy. So that is the part of my research.
Great. Yeah, I mean, it is interesting. At the same time, I have another question related to this. A imbalance to মানে তুমি য'ত just এইমাত্ৰ তোমাৰ answerটো শেষ কৰিলা যে imbalance-টোত different parameters থাকে. So where does your research stands in understanding like the factors that contribute to this imbalance?
That's a great question. So definitely, so the imbalance word to what creates that imbalance? I mean, hetu parameters or forcing agents or radiative forcing. So why forcing? Because it forces the temperature to change or climate patterns to change. Hetu karne ekita radiative budget or radiative forcing to connected hoy. So forcing agents can be natural and can be anthropogenic, man-made. So some of the natural junto hoy, there can be a change in the solar radiation itself, or there can be change in say there can be a volcanic eruption, or so those factors are there. But and there are other factors like clouds and aerosols. So my interest is particularly in understanding the role of aerosols in the radiation budget. So more to study more, I mean, when I say me, it's just not me, but the entire my team of research. So we have been, so I would like to, I think at this point, it is also important to mention about India to important projects where I say just to dedicated to radiative forcing. So and aerosol research. So so it is initiated by the Indian Space Research Organization's Geosphere-Biosphere program. Aerosol Radiative Forcing over India boli eta project ase junto 𝘓𝑝net. So etu projector bhitorot different parts of India under university or research institute or continuous measurement of aerosols. Sometimes in some of the institutes also have trace gases or meteorological parameters to measure high. So out of those places or network, Amar Dibrugarh University, we have a very long time measurements of aerosols. And this was initiated by Professor 𝘕𝘠𝘆. He was also my PhD supervisor. And after initiated in 2001, it was taken forward by or also like participated as a PhD student, postdoctoral fellow by my another supervisor, Dr. Mukunda M. Gogoi. He's now currently a scientist in the aerosol group in ISRO SPL. And then it was followed by Dr. Binita Pathak, who's also my mentor from Dibrugarh University, and then it was carried on by several other students like myself. So it's an initiative that requires like a lot of effort to just measure the aerosol radiative forcing. So, and similarly, we have similar organizations here in the United States, junto ami yadkom atmospheric research program or bhitorot amar arm measurements thake. So these kind of efforts are taken by all the different places these are taken like in different places in the world, including India. And so we, as a researcher, we use this data to analyze, to study more about the aerosol radiation interaction. So maybe I have diverted a little bit from the question, but so my research fits into these efforts that are put in forward by different organizations.
Yeah, I mean, no worries about diverting because it's anyways very interesting. So, Harry সুধিব ওলাইছিলোঁ মই যে you have mentioned তুমি যিটো Dibrugarh University effortৰ কথা কৈছা যে there are like long records of aerosol measurements. Now you are working in BNL and you were in the Michigan University as well. আৰু আমাৰ আগৰ তুমি Dr. Binita Pathakৰ কথা mention কৰিছা. She also was a speaker in one of our sessions earlier. গতিকে তেওঁৰ কথাৰ পৰা আৰু Dr. Gayatri Kolita আহিছিলে আমাৰ sessionত. So তেওঁলোকৰ পৰা আমি যিখিনি শিকিছিলোঁ, that was like aerosol is specially varying. মানে অলপ দূৰে দূৰে aerosol বিলাকৰ ধৰণ বা density change হৈ থাকে. So, and you said your research is about different efforts which are going on in measuring aerosols in different places. So how different it is measuring aerosol in Dibrugarh University and measuring aerosol in New York, because India in general would be more polluted. So yare aerosol bilak ba New York or aerosol bilak. So how different or how similar is it?
Yes, so I think যেতিয়া মই ইয়াত আহিছিলোঁ সেইটো question to more that was in my head as well. মই just মানে এইটো question to এতিয়া বুজিব start কৰিছোঁ বুলি ক'ব পাৰোঁ. So in India মানে there is like if you divide India in terms of aerosol loading bolikung, because these aerosols are like scattered in the atmosphere. So it is not just spatially heterogeneous, it's also vertically heterogeneous. So in that আমি যোনটো measure কৰো আমাৰ Indo-Gangetic plains area আছে, plains আছে, সেইটো মানে বহুত polluted আছে, and that polluted area is so much different from our Northeast India যোনটো polluted region আছে. So if we compare that with the observation in the United States, particular matter khetrat mane it is very less. It is like PM concentration boli kaun, if you, I think that particulate matter is a very common word. So particulate matter, these are the mass concentrations of the aerosols with size less than 2.5 micron, hetu mane size or bhitor junto as it is PM 2.5. So junto etu is like, for example, in India, jetia bahut polluted thake, it goes almost to 100 microgram per meter cube. Aru junto yat thake, it will be like, when we measure regularly in India, in Dibrugarh, for example, to 30 microgram per meter cube thake. And yet, junto ami measure koru say in New York, ami regularly like maximum 30 microgram per meter cube eto hobo pare, but it can go beyond, because ami junto yat New York ot ami recently at a bahut dangor wildfire in Canada ami face korisilu, junto Canadian wildfire junto smoke asile higita mane it arrived to New York. So so what I mean to say is, it really doesn't matter if your region is producing any emission or not, because it is not just the emission at that particular location. It can be impacted by the emissions from the other regions. So so I give an example of New York's New York was impacted by the wildfire emissions from the Canadian wildfires, right? So similarly, amar junto Ohomot, there is a huge impact of biomass burning. Junto amar southeast or pora bahut biomass burning junto hoy. Egita transport hoi pine amar northeast or ahe. And then also amar junto Dibrugarh is easternmost part of India. So amar junto jodio it is on the easternmost part of India, it is still affected by the emissions from the Indo-Gangetic plains. So it is transported via long-range transport. So aerosols, as you said, it's very complex, and it really is very heterogeneous, and it is not just because Hitu region polluted hot. It can be because it is impacted by the other regions in the world. So yeah, that's how I think of.
Yeah. Thank you for a nice overview of how even remote emissions can affect us and how complex it is. So H2 complexity about aerosols, and আমি যেটো জানো যে these observations eventually আমি observation বিলাকৰ ওপৰত base কৰি পেলাই we try to model them. And you said your research also involves modeling of aerosols in a climate model. So how do you do this? Like how does a model try to mimic the real world?
So basically models to বিভিন্ন ধরনের models থাকে, or বিভিন্ন level or models থাকে, like some models can be 0 dimension junto ami box model boli kong, so to Lagrangian hoy, it varies with space or varies with time, but at a point dot mane enike jabo pare. So that's mostly like a Lagrangian system. Aru ami second type of model would be like radiation models, like 1-dimensional model junto eta location or pora based hoy, but it to vertically change hobo pare. So it is changing over your vertical direction. So itu amar ar beleg dhoroner model hoy. Ar ami junto weather forecast or kotha huni thaku, Hetu both regional or global or hot. Mane everything is included. Mane it is a mixture of basically all the atmospheric processes, and it's a mixture of all the meteorological phenomenon. So hetu run koribole, for example, the weather forecast model with chemistry run koribole amar bahut input lage. Input of the weather of the meteorological activities like rainfall, humidity, wind, temperature, egitar amar information lagibo. Tarpisot grounder, we have to tell model ki ami mane I want to model over say Northeast India. Northeast India amar terrain to bahut complex hoy. It has lots of biodiversity. We might touch upon that topic later, but it has a rich biodiversity of say trees, different types of trees or different types of land surface. Ito ami modelot kobo lagibo. And also we also have to tell model ki amar yat emission ase. I want those emissions to be there in the atmosphere, but I have to tell the model that yat emission ase. So our measurements are very helpful to feed in those information. Ami juntu ARFINET or para measure koru igita information. Yeah, for any network in the world, ami juntu measure koru ami direct model or input dibo paru. Ki this is the observation I have, and the model will use its physics and all the chemistry and do its calculation and numerical calculation and will produce the output. So that's how we use the observation to the model. And also, I think it goes without saying that these observations to truth hoy. We call it ground truth. So these are also used to validate our models, because we have already seen that there are so many models out there. Within the models, there are lots of uncertainties. So kuntu model bhal hoy. Like there are CMIP models, there are different ranges of models. So I mean, we are not sure like which model works best for which process. So we use our observations to validate our models. So it's a win-win situation if we have lots of observations.
Yeah, great. Yeah, go ahead.
Okay.
Please.
Yes, sorry. Since we are talking about models, so আমি considering Northeast India, yeah, like Assam, আমাৰ যেনেকুৱা complex terrain হয় বা যেনেকুৱা ধৰণৰ geographical location, everything, considering everything. So how difficult is it to predict, to use the models in our area?
Yes, that's again a great question. Ami mane hitu problem to ami hodai face koru. You have picked up a very right problem there. So ami juntu observation. Sorry, the model has to run following a certain resolution. Aru ami juntu grid hoy, say 10 kilometer by 10 kilometer model ami jun run koru. Northeast itu iman bhalke kam nokoribo pare, because you know that 10 kilometers or bhitorot kiman terrain change hobo pare. If you go to say the hills in Meghalaya, I'm talking about more like hilly region. So ami juntu to mane 10 kilometer bhitorot there can be lots of ridges, or there can be a lot of change in the type of vegetation or land use, land cover. So hitu ami directly if you want to capture the reality of what's going on in Northeast India, ami bahut high resolution model run koribo lage. So high resolution model maybe say, actually the high resolution model is like 200 meters, but it is very expensive computationally expensive to run a model in 200 by 200 resolution. So I mean 3 kilometers run koru, 4 kilometers run koru to capture that area. But you are right that because of our complex topography, it is really the model simulations get a lot expensive. So yeah.
Right. And one more follow-up question. like when we design a model, like the parameters you would include, right? But considering, let's say again coming back to Northeast, মানে যেতিয়া আমাৰ তাতে recent timeত যেনেকুৱা ধৰণৰ deforestation হৈছে বা land surface like kind of uses or যিটো rate of change হৈছে, so model বিলাক to, I guess from my experience, human rapidly, like it's a real time evolve নহয়, right? It's a process, it's a long process. So তেতিয়া যদি সেই deforestation বা land surface cover uses বা এইবিলাক parameters যদি আমি include কৰিব নোৱাৰো, import কৰিব নোৱাৰো to the model, তেতিয়া হলে আমি কেনেকে মানে considering again the complex terrain, the cost, benefit and everything. So how do you like তোমালোকৰ expert বিলাকে মানে how do you process such kind of complexities?
So that's a big problem. So however, I will try to speak something positive in this particular way so that it makes us feel better. So so when we do the simulations, for example, Northeast India pora, at a season to avoid that complexity, at a season of run koribo paru model, not for like 10 years. যেতিয়া আমি 10 years or karne 20 years or karne ami climate simulation koru, তেতিয়া আমাৰ scenarios থাকে যোনটো egita information to include হয়, like change not to realistic extent, but to some extent these informations are fed into the model, like our carbon dioxide kenekwa change hoise, our temperatures, what expectations. So we have some expectations, we try to tell that to the model. But in general, suppose if we are trying to just model over pre-monsoon season, say March, April, May in Northeast India, which is the highest aerosol loading period in Northeast India. Hetu time just we want to capture aerosol impact in the high aerosol loading season. Tete ami himan to consider koribo nalage. Because the changes in forest, these are long-term changes, as you mentioned. Land use, land pattern is a long-term changes, but it may not impact, it may not change a lot in say 3 months. So that's how we can justify, but you are right. A lot of things are happening every day, like there's a change in vehicular counts every day. It has been increasing over Northeast India as the census is what it says. So all those small informations are really hard to put in the model. And that is also one of the reasons why there is a word called uncertainty that is always associated with the model results. Yes.
Yeah, I think that's a very nice way to put it, that in a positive way, a scenario bilak amar ase, mane modeling, atmospheric science ba meteorology scientist bilakor majot jitu heri je scenario bilake amak at least gives us a boundary condition, even though it may not be exactly the real scene, but it gives us what if kind of situation, like the next worst case scenario. So that gives us some bounds. So yeah, something which you just mentioned and said we probably will discuss, which definitely I wanted to discuss, is a aerosol and biosphere interaction. So tumar already to be mentioned korisa je Okhomot terrain. So in addition to being like in addition to having a complex terrain, Okhom, we know that it's a hotspot of biodiversity. So in a hotspot, how does like aerosol by aerosol radiative forcing or biodiversity, so a biosphere আৰু aerosol বিলাকৰ মাজৰ interaction কেনেকুৱা হয়?
Mhm. Just go to the base maybe. So the biosphere atmosphere interaction is very dynamic, and it's also a very intricate process in understanding climate change. So we should remember that. So that's our motivation for our whole research. So in simple terms, like as you mentioned, that Northeast India is one of the 35 biodiversity hotspots in the world. Our whole region, not almost 60% forest, more than 60% to forest cover assay. So, and these forests are rich sources of aerosols or precursors for aerosols. So precursors means these are gases like volatile organic compounds bolikong, ami VOC bolikong. Juntu biogenic VOC juntu it is emitted from the forest or trees or plants. So it more than 60% of the land ase jodi covered with forest, hitu kiman biogenic precursors produce koribo pare. We can think about it. Is yet unknown. It is there in the models, but we are not there yet to measure the VOCs. I'll talk about the complexity in the observations at the end. So, and then the other part is more like primary. So those VOCs produce secondary organic aerosols. Secondary means gas to particle conversion, 𝘠𝑗𝑛2. But there is another type of aerosols which are primarily produced from the forests or from the vegetation or terrestrial biosphere in general, which are pollen, fungal spores, bacteria, the list goes on and on. And these pollens are, so my interest is particularly pollen and fungal spores, but I think I'll just touch upon pollen because of the time. So the pollens are like bigger sized particle. We are all well aware of pollen grains, and these have impact on the climate plus health. So as we know that during the pollen season, amar bahut pollen allergy hoy. So what is the cause of those pollen allergy, and what kind of impact that it can, what impacts can it have on the climate is the big question here. So that is one of the areas of biosphere atmosphere interaction. So that is where my research is based on.
Okay, I think it's a nice point. So do you collaborate? So karon pollen, you said manuhar karone health hazard. At the same time, I didn't really know anything about pollen affecting weather. So atmospheric scientist are biosphere scientists. Do you collaborate to study pollen together?
Yes, I think those initiatives are also being done at Dibrugarh, but I'll talk about my experience. So we do collab because it's, as you said, it's a joint venture. It involves not just aerosol chemists or aerosol physicists, but it also we need some input from the biologists as well. So it's a combined effort. So in my recent project, what we did was we tried to make a parameterization or developed a code that can detect the fate of pollen in the atmosphere. So that is our part of the job, is how we want the pollen or what we want to study in the pollen. What we want to study in terms of the role of the pollen in the atmosphere is my part. But of course, I need to get that information ki kiman pollen emit hoya ase from the surface. So maybe not always we can do everything. Like not always can we measure, model, and do everything. So sometimes we take information from the biologists who have information about the pollen counts or share information with one another. So also our atmospheric sciences is a lot about collaboration and data sharing. And I think we did not touch upon one of the types of main data source in today's talk was the satellite observations,
Yeah.
satellite which are being running for decades and just looking down on our Earth and just trying to measure different parameters at different layers in the atmosphere. So it's just like a great amalgamation of all these different efforts of ground measurement, of aircraft measurement, of the satellite measurement and modeling using all of those. So yeah.
Yeah, that's really really nice. I mean, I didn't really know about these pollens, as I mentioned already, and I think so. And you also mentioned like there has already been initiatives in Dibrugarh University for studying pollens and collaboration between biologists and atmospheric scientists, which is very, very nice to know. So, so are you still working on this pollen? Like what you said is like how does pollen gets emitted from its source, and how long does it last in the atmosphere? Sure. Like, can you tell us about like what is the lifetime of a pollen in the atmosphere?
So generally for aerosols, it's almost like a week or 5 days is what is being experimentally recorded. But for pollens have very interesting characteristic. So pollens to 10 micrometer or size or high, like more than in few micrometer or size or high. But once they are released, যেতিয়া বহুত humidity থাকে atmosphere ভিতৰত, they have a tendency of like rupturing. So rupture মানে to burst হয়, or burst হয় পিনে এটা single pollen can get converted to 1,000 pollens. So it is, you can imagine it, horu pollen into 200 nanometer or size or approximately. It atmosphere goi pine, it will make clouds or interact with clouds. It can interact with cloud formation process or rain formation process, and finally these are deposited on the surface. So there's like a cycle of their lifetime. I mean, this is the general cycle of the pollen. But as I said, the most interesting part about pollen is one big pollen can burst and produce 1,000 smaller pollen grains. So, which is very rare, and it's that is one of the reasons why so there's a term actually in our field called thunderstorm asthma. So at Australia, the Dangor incident hoisile in 2016, but you can check the year. So 2016 or Melbourne, Australia, mane eta Dangor pollen emission or pora thunderstorm jeta hoisile. So thunderstorm can also break these pollens into number of particles. So hetu together jeta hoy pollen emission, thunderstorm. So it produced large number of pollens, and it created lots of health emergency situation that also killed people and hospitalized like hundreds of people over the night. So it was thunderstorm asthma boli koi. So it has both health impacts and, as you mentioned, there's like a climatic impacts related to pollen. So yeah, I'm currently very much interested in studying them using measurement and model. Yes.
Yeah, that's really interesting. Nobonita
Yes.
kiba khudibo olaisila niki?
Yes, we have a question in Facebook.
Oh, okay.
Yeah, so Bijit Kumar Banerjee Hudise, the satellite pictures show a higher value of aerosol optical depth in the Northeast, West Bengal, and Bihar region. Is it the wind, or is there anthropogenic causes for that?
Yes, so that's again a great question. So as I mentioned, so these higher loading of aerosols are, if you see the seasonal variation, it is sub season or nohoy. It's not an everyday process. Especially in pre-monsoon season or northeast or even in some of the parts in Bihar, a region or bahut high aerosol loading hoy. Of course, there are emission in the region, of course. As I already mentioned, it is also the impact of long-range transported aerosol. Ami junto westor pora Saharan desert ase, hitur pora desert wind to aipine bahut desert aerosols to amar dust aerosols to aipine amar region not ahe. There is a reason why this is happening is because amar junto northeast ase top what amar Tibetan plateau, Himalayan range ase. Around our south, we have the three mountainous region, and we also have mountains of Yannan in the east. So our enekwa at a tinta sided block hoy, and suppose this is Dibrugarh. So at west side to khali thake. So jima yar west or pora mani desert dust or Indo-Gangetic plains. Egita sob emission to eneke jetia ahe, it just gets blocked and settled because it to mountain or pora ulai jabo nwaribo pare. So generally, there is this lot of aerosols being continuously transported. Or at a recent study, study korisilu from our group in Dibrugarh that almost 25% aerosols to ahi thake from the west. So yes, there are very high aerosol loading periods sometimes in Bihar and Guwahati region. And even Dibrugarh, because of these long-range transported aerosols.
Yeah, it's a very, to me, the way you were showing that the aerosol comes, I think it's kind of a nice visual animation of aerosols moving from the west to east. So এনেকুৱা ধৰণৰ simple
Bitter. I have a
sorry.
follow-up question from the audience. Sorry, the participant is here, but I will anyway read out the question. So he followed up that is there any connection between these aerosols and higher storm convection and the hydrometer interaction?
That's the hottest topic of research right now and most complex. So we didn't touch upon that today. So there is a term called aerosol cloud interaction. So aerosol, so let's just give you a very short brief introduction. So aerosol chuntu hoy, it acts like a nucleation point. At a nucleus fully act kore jor it gives a surface for the water vapor that condense hobole. Or water vapor jete condense hoi thakibo, it makes like a cloud droplet. Or bahut aerosols thakile etu cloud droplet eneke thake. So that's how basically aerosol can make cloud, or how aerosol gets involved in making clouds. So in terms of deep convection, now there is actually a scientific debate hoye ase ki aerosols to deep convection or bhitorot, does it have a positive influence or does it have a negative influence? So I don't think I am capable of answering that question, ki deep convection or ki kore aerosols, because sometimes deep convection deep convection both vertical updrafts thake, or vertical updrafts like cloud to sometimes when we look up the sky cauliflower nisina dangor tall clouds form hoy. So cumulonimbus clouds eneke. So deep convection to teneke hoy pin, it keeps making cloud. But what aerosol does to that is indirect effect of aerosol. So there is always a debate. Some of the studies have found that deep convection or pasot rain to komai ya rain to bari diye. So that's a part of a debate that I'm not directly involved, but it's a great research topic. Yes.
Yeah. Thank you.
Thank you, Bijit, for those questions.
Yeah. Thank you, Bijit, for that question. I think that's what we have noticed during every session. When we towards the end of the session, we actually kind of warm up and it starts to get interesting and exciting, and that's when we need to finish the session. Yeah, But anyways, this was really nice. So the way you were explaining, in very simple, with a very simple approach. So on that note, can you suggest something like, can school kids get involved in doing some fun projects to understand aerosols or aerosol cloud interaction or movement of aerosol, or yeah, it can be anything, like the fun projects, and at the same time so they will get some knowledge.
I think yes, this could be many the school students, many school students come and do summer intern বুলি কয়, যোনটো summer vacation যোনটো টাইমত কোনবা এটা ল্যাবত গৈ পিনে ইয়া ইউনিভাৰ্চিটিত গৈ পিনে মানে projects এটা কৰে, so they do some work completely done within a few weeks, so that's like a very short project. So তেনেকুৱা ধৰণৰ project আমি কৰিব পাৰো, মানে for example North East India আমি বহুত লোকেশনত আমি already study কৰি আছো as a team from different universities in Northeast India, not just Dibrugarh University. We have the Northeast Space Application Center. They also measure a lot of aerosol properties, and there is other universities too. So but still there are a lot of places we haven't digged into it. So I think like and we don't know what's happening in terms of, say, aerosol number concentration or mass concentration. So hitu karne we can use low-cost sensors. Well, low-cost sensors may not be research relevant, top-notch research relevant to hobo noire, but they can be used to find some information, to have some idea, and the school students can actually use them or go to whatever region they are interested. So I think they are the next generation, like they are the voice of the next generation, and they might have different interests. They might have different interest of going different places in Northeast India junta ami explore nai kora, so hitu ami koribo paru. And also there is as I mentioned earlier, mane amar instrument measurement, there's already a lot of complexity in the measurement area. Ami sob measure koribo noaru because amar khetrot hitu instrument nai. So I think the students can also try to dig into those small apparatus or instruments, labor bhitorot. They can dig and check how is that instrument being operated. So that could itself, to understand to instrument or bhitorot ki hoy ase, could be one of the projects. And and that costs money because you have to buy the low-cost sensors. But and you have to travel. So if and we don't need to spend that money because we have, as I mentioned, we have the satellite data. So it was satellite data loipine ami long-term variation in the land surface koribo paru, long-term variation in temperature and humidity teniko sob koribo paru. So that could be another important projects. But I think it is on our end to maybe help them with writing code in some programming language juntu they can access, and give them data and then show them how to do. But I think it's doable.
Yes.
So yeah, I will ask a question since we are going towards the end. So since we are talking about involving students like and small projects, so more question to hold. Since you were working in New York, I like one of the best ambience or infrastructure wise best area. So more question to hold. So while you are there at this moment, so can you recognize some gap areas, like one or two gap areas that exist in our area, or probably in the retrospect or whatever way? So would it be possible for you to identify like one or two gap areas je ekhini probably agote address kora hole in this particular research, so other areas would have made much progress, or would have been like much easier for you for your research, so that way?
Yeah, think that's a thought-provoking question. So luckily, when I was in Dibrugarh, I think mane bahut lucky that there are these networks in the, as I said, 𝘓𝘕𝑛𝑦𝑒t. I have to mention this, that 𝘓𝘕𝑛𝑦𝑒t was led by Dr. K. Krishnamurthy, and there's Suresh Babu from SPL, who's been continuously putting this effort, including Mukunda M. Gokoi, as I mentioned. So they have been doing this continuous effort to measure these parameters. So I personally did not feel any particular need of having some that I didn't feel like there was a gap in my research or something that was not there for me. But one thing I think would be great is to have a bigger computational resource, which again is already initiated in the universities that I mentioned. But that is one. Computational resource is a big problem, not just in India, but here also. Like, so that's one. And the other thing would be like, as Northeast is very heterogeneous in terms of lots of properties, I think more dense measurements would be great. Dense, and it need not be like a continuous running experiments, but maybe like short term, but attacking some good problems, like 𝘓𝘢𝘃 biomass burning hoya, say, go there and measure it. But there should be like a spare instruments ready to tackle all those things. And I think that would be great. Yeah.
Okay, great. So we actually have 1 minute of our scheduled time. So I want to ask a very brief question, and I have one more pending thing to do. So, which is to ask, did you paint those paintings behind you?
Oh, yeah. My new passion started a few years back, but yeah, I love
Yeah, they
painting.
are actually beautiful. I don't know how many years back you started painting, but they are beautiful. And one more thing I very quickly wanted to ask, since you have mentioned, like, you have done coding and you mentioned about availability of computer resource. So what kind of software do you use, or what kind of language do you use, just for if anybody like from college level they're listening, probably that would be informative.
So all the model parameterization, mostly in like a weather research forecasting model, 𝘓𝑚 that we call in short, they are in Fortran. It's fortunate and unfortunate both. I mean, we've all learned Fortran, but I don't think like today's generation kids would learn Fortran directly, but they will definitely have an idea of Python or MATLAB. So I mostly use Jupyter, Python, like use Python via Jupyter, or we also have Julia. So yeah, basically MATLAB is not a language, but like a great tool to work with. And we have Jupyter, and of course I think in atmospheric science, all our codes in all the bigger parameterization schemes they have used is Fortran. So I think these three is what I'm comfortable with.
Okay. Yeah, that's yeah, just wanted to put it out there, that what kind of language or tools you use. So yeah, unfortunately we will have to finish today's session.
think আমি 5 minute stage to open করে দিব পারো, if any audience have any follow-up questions.
Yes, we can delay for extend it for 5 minutes if anybody wants to ask anything or comment on anything. Otherwise, yeah.
Yes, Binita.
Hi, Navanita Vidud. মই actually travel কৰি আছিলো, so quickly মানে just video on কৰা নাই আৰু হেৰি তামান্নাই বহুতখিনি cover কৰিছে মোৰ অকমান network disturbance কাৰণে মই আকৌ চাব লাগিব তাই গোটেই কথাখিনি but okay so she can join actually তাই তামান্নাৰ কথা আৰু মোৰ কথাৰ মাজত তোমালোকে লিংকটো পাইছা ন বিচাৰি
Yes, yes.
yes biological aerosolৰ কথাখিনি তাই মানে খুব ধুনীয়াকে কৰি লাগে আমি হিমানটোলৈকে যাবগে পৰা নাই definitely কিন্তু এই যে আমি সেন্সৰ ইউজ কৰিব পাৰো আৰু প্লাস এই গ্ৰিড মানে গোটেই আমাৰ নৰ্থ ইষ্টখন গ্ৰিড বক্স কৰি পেলাই so that in each grade আমাৰ observation বোৰ আহিব পাৰে সেই
Yes.
বস্তু মানে সেই কানেকশনটো খুব দৰকাৰী আৰু তামান্নাক আমাক ইন ফিউচাৰ লাগিব তো মানে কি আৰু কোলাবোৰেশনটো দৰকাৰ হ'ব তাৰ মানে গোটেই প্ৰসেসটোত আমি যদি আগবাঢ়িবলে মানে যেটো আমাৰ প্ল্যানিং তোমালোকে ভাবিছা বা আমি সবে লগ লাগি ভাবিছো even in navigation
yes বিনিতা মই ৰখাইছো সেইখিনি কথা আমি পাছতকে পাতিম হেল্ল
yeah all right
মই কৈছো আমি সেইখিনি কথা পাছতকে পাতিম if you have some questions then let's address now or
not a specific question right now
okay.
but it was nice I think তোমালোকে ভাল পাইছা সাগে তাই লগত
Yes, it was
really
very nice the way Tamanna explained the things. Yeah, I guess আমি সামৰিব পাৰো নহয় নে?
Yes, nobody has a question then probably we can wrap up.
Yes, and to the speaker, anything if you would like to mention quickly that
I mean yeah, sorry. Please go ahead.
Go ahead. Okay.
Yes, Tamanna, please go ahead. Yes, sorry.
Yeah, I think I had a great time talking to everyone, and thank you so much again for having me. And I appreciate what you do, and yeah, I think I really enjoyed it, and I understand the importance of the platform like this. So I appreciate all your work.
Thank you so much.
Thanks a lot. So সকলোকে ধন্যবাদ আমাক কিবা কোৱেশ্চন থাকিলে ফেসবুকৰ যেটো ভিডিও আছে তাৰ তলত কোৱেশ্চনটো পোষ্ট কৰিলে we will be happy to forward it to Tamanna আৰু yeah otherwise এনেও আমালৈ ইমেইল বা যোগাযোগ কৰিব পাৰে in case of any question or comment আৰু finally thank you Tamanna again thank you Navanita for co-hosting thank you Anna Jory for giving us the platform and Rishi for conducting the session so take care and goodbye for today.
Yeah. Thank you.
Yeah, thank you. So we will